All right, everybody. Day 1 notes of Unit 6. Let's get started. So we're working on the Pythagorean Theorem. You should be well accustomed to this from algebra. Use it plenty. The important thing about the Pythagorean Theorem is, first off, it only applies to right triangles. The most important thing after that is knowing which side is the hypotenuse. That's going to be the one opposite the right triangle. And it's also going to be the longest side always. So it's a nice check if you ever are doing your math and you calculate a number that is smaller than one of their two legs, you know you made a mistake. And these legs are kind of interchangeable. We'll talk about that when we get to the formula. But how you plug them in to the formula does not matter. And obviously, you can't say, switch the numbers. If one's 8 and one's 14, you can't switch them. But when you're doing the formula, it doesn't matter which one you call which. So here's some information about Pythagoras. And you can hit pause and read that if you like. Now, here is the actual theorem. A squared plus b squared equals c squared. And this part right here is what I was talking about. A and b don't matter. They are interchangeable, how you enter the numbers. But what is always the same is c. And the reason I talk about that being important is a lot of times people want to always plug in their numbers for a and b and never for c. And it depends on what you're given. You got to pay attention to the letters. Okay, so number 1. I personally suggest you always start off by writing a squared plus b squared equals c squared. Then fill in your numbers. Now remember, I also suggest you go ahead right away on every problem, find the hypotenuse and label it c. Again, here, it doesn't matter if this is a and b or if this is a and b. It makes no difference. But c is extremely important. So I'm going to plug in a is 3 and b is 7. Now you can call it c squared or x squared. It makes no difference. So this is 9 plus 49 is c squared. So c squared is equal to 58. But I don't want c squared. I want c. So to get rid of squaring, I square root. Whatever I do to one side, I must do to the other. And then if I take the square root of 58, I get the decimal 7.6157, a bunch of sevens. So depending on where you're asked to round it to, this would be 7.62 or just simply 7.6. Whether you're asked to round to the hundredths or tenths spot. All right? Number 2, I'm going to come up here a little bit to have some space. Now here again is why I say it's important to write this down. Because if you don't, a lot of times what people do is this, and don't write this down. They do this. 6 squared plus 18 squared equals c squared. And the reason that's wrong is the 18 belongs here. Now remember, don't write this down, but I'm going to work this out for you. 6 squared is 36. And 18 squared is 324. Well, that would be 360. So if I take the square root of 360, I get 18.97. There's no way that this can be 18.97. It has to be smaller than the hypotenuse, which is why it's very important to label. And now when I put these in, I'm going to say 6 squared plus b squared equals 18 squared. So that's going to be 36 plus b squared equals 18 squared, which like I said is 324. But instead of adding 36, I want to subtract 36, which gives me b squared equals 288. I take the square root to cancel that square. I do it to both sides. And then I take the square root of 288, which is 16.970. So 16.97. If you rounded, it could be 17.0. And I put the 0.0 just to show that it was rounded up and not a whole number. Okay. Example 3. Again, that's my C. It's very important. Here's my A, here's my B. Now, A squared plus B squared equals C squared. X squared plus. Now here's the problem. This is x plus 2 squared. Whoops, this was be a 10. Sorry, a little technical problem. Now, I've got to talk about this because this happens all the time. In fact, it happened after I told somebody not to do this. You look at this often and want to say, oh, this is just simply x squared plus 4. And that is incorrect. That is not true. We can't do that. You can't just send that 2 in like that. That's not how it works. This actually means x plus 2 times x plus 2. You have to multiply, distribute, FOIL. X times x, x squared. The outside terms, 2x. The inside terms, another 2x. And this is the part that got lost. And the plus 4. If you just squared and wrote x squared plus 4, you're missing out on this whole middle part, which is 4x. So, this ends up being x squared plus another x squared plus 4x plus 4 equals 100. So now, we need to join like terms. 2x squared plus 4x. That's not an x, that's an x. And then 4 minus 100 is negative 96. Now I could factor this right now, which you did in Algebra 1, but I'm going to factor a 2 out. Always take the GCF out when possible. It gives you smaller numbers to deal with. Now, this is going to factor to x times x, and I need two numbers that multiply to give me 48 that differ by 2. Well, that's 8 and 6. And since I want more positives, I want plus 2 left over, it's going to be like that. Now, I'm going to set these both equal to 0 and get x equals negative 8 and x equals 6. Now, there's a problem with this answer right here. If we go back up and we plug in negative 8 right here, x is negative 8. That's not possible. You cannot have a negative distance, a negative measurement like that. Okay? If you're 5'10", and you stand on your head, you're not negative 5'10". Okay? If I run a 100-yard dash, if I run back to the starting line, I didn't run a negative 100 feet. I still ran a yard. I didn't run a negative 100 yards. I ran 100 yards both ways. So there's no negative distance. Now, there are times when a negative x can be okay. If, for example, I had a triangle where I had x plus 10 and x plus 15 as sides, and I said x is negative 8, well, 10 minus 8 is 2, and 15 minus 8 is 7, and that would work out. And so you can't just automatically say negatives are wrong, but if you plug them in and get a negative distance, it is wrong. So when I say x is 6, and the other side is 6 plus 2, that third side is 10, there you go. My triangle has the lengths of 6, 8, and 10. Okay, on this one. Again, I have my a squared plus b squared equals c squared. I identify my right angle and my hypotenuse. Here's my a and here's my b. 10 squared plus 5 squared equals c squared. That's 100 plus 25. I take the square root of both sides. And the square root of 125 is 11.180, or 11.2, depending on how you round it, or how you're asked to round it. Okay, this problem is actually not in your notes, but I'm going to go over it anyway because it's a good problem. Find the length of a diagonal with length 8 and width 4. Now, if you didn't have a drawing like this, you'd have to provide it, but it is here. So we're looking for, it's a rectangle, right angle, we're looking for C. That's simply 4 squared plus 8 squared equals C squared. That's 16 plus 64, which is 80. So you take the square root of both sides, you get C equals 8.94, or 8.9. Okay. Number 2. This is 6 and this is 6, making 12. So here's my hypotenuse. So I have a squared plus b squared equals c squared. I have x squared plus 6 squared equals 10 squared. So that's x squared plus 36 equals 100. Subtract, I get 64. So I take the square root, I get just 8. No big deal. Now this next problem is a challenging one because it's not hard, it's just 2 steps. It takes 2 steps to solve this problem. So I'm trying to find this hypotenuse over here. I have my A, but I'm missing B right here. Now how can I find that B? Well, over here I have another right angle. Here's my A, here's my C. I can find B. So I'm going to do A squared plus B squared equals C squared. 8 squared plus B squared equals 9 squared. So it's going to be 64 plus B squared equals 81. Now 81 minus 64 is 17. So the square root, B equals the square root of 17, which I'm actually going to leave as a square root, because now when I do A squared plus B squared, it's going to go, the radical is going to go away, like so. 14 squared is 196. Plus, that undoes the radical, so I just end up with 17. So 196 plus 17 is 213. Now if I square root both sides, the square root of 213 is 14.594. So that would be 14.59 or 14.6, depending on if you're asked around the hundreds or tenth spot. And then we have one last problem. Solve for x. Now, this one's kind of a tricky one. Requires a little bit of artwork. I'm going to draw a line right here. Now, if you notice, that line is the same as that right there. I formed a rectangle, so that is 7. Now this line right here is, oops, okay, that didn't work. Try this. So I'm going to take this line, the board is just not being cooperative. Let's see if I can get this to work. I'm going to take this line and drag it up here, which means this piece right here is 6. Well, if the whole thing is 10, and this piece is 6, that makes this 4. And now I have my right angle. There's my C. So 4 squared plus 7 squared equals x squared. 16 plus 49 equals x squared. X squared equals 65. And square root both sides. And I get x is equal to 8.062. So 8.06 or 8.1, depending on where you're asked around. And that's it.